All right, you guys. So today we're going to start just sort of discussing some concepts, all right? We're talking about vectors. You've heard me talk about vectors a few times, and we've had vectors and we've had scalars. Scalars only have magnitude, and vectors have the magnitude and direction. So we've said that displacement is a vector, velocity is a vector, acceleration is a vector, speed is a scalar, time is a scalar, distance is a scalar. But now we need to talk about what a vector actually is. So another important part about vectors is when we're drawing them, their length is going to matter, okay? So for instance, if let's say we had a displacement of positive 5 meters, the vector might look like this. It's going to the right, it's positive, and it's about this long. But if we had a displacement of positive 10 meters, the vector would be twice as long because now we're going 10 meters instead of 5 meters. So the vector length does matter, and yes, there needs to be an arrow on the end, okay? Pointing in the direction that the vector is going. All right, another thing that vectors have a lot of the time is an angle, and that will give the direction too. So right here, these would have an angle of 0, right? However, you could be going, let's say this is 45 degrees, 8 meters, okay? So here, this vector would be 8 meters, 45 degrees, north of east, because this would be the positive x direction, this is the positive y direction. So remember, in a coordinate system, this would be north and east. So this vector is 45 degrees north of east, okay? Let's look at a really quick example together though, okay? This is called what's the velocity? So say you're riding in a van on a straight highway. The speedometer reads 45 kilometers per hour. All right, 45 kilometers per hour. What additional information is required to specify the van's velocity? Okay, so for example, we would need to know which direction it's going. So we could say if the van were going this way, it would be 45 kilometers per hour north. If it were going this way, it would be 45 kilometers east. If it were going this way, it would be west. If it were going this way, it would be south, and so on and so forth, like north of east or south of west, okay? So remember to always include that little bit extra, that direction, okay? Now, vectors get broken down further when they're like this though, okay? We call them components. So you might be wondering, what are vector components? Well, let's look at this as an example, okay? Let's say we have a velocity vector, okay? Now, it is 35 meters per second. So this velocity vector, 35 meters per second, okay? And it is at an angle of 57 degrees north of east, okay? And I ask you to find the components. Well, all that means is that we want to find the x and y of this vector, x and y. Now, what's really nice about this is that you'll notice this makes a right triangle, which means that this angle's 57, this angle is a right angle, so it's going to be 90. And then this angle right here is going to be 33 degrees. How we know that is that there's 180 degrees in a triangle. So 57 plus 33 plus 90 equals 180. Now that we have that information, we can find the x and y coordinates. So let's go ahead and find the x coordinate, all right? We all know sine, cosine, and tangent, right? Our SOHCAHTOA. Well, I am impartial to cosine. I like to use that as often as I can. So this would be the adjacent side to 57 degrees. So I would know that cosine of 57 is equal to the adjacent over the hypotenuse, which is 35. Okay, now to solve for x, all I need to do is take this 35 and multiply it by this cosine of 57. So I'm going to have 35 times cosine of 57 equals x. When we type that in, we end up finding that x is equal to 19.1 meters per second. Then we need to find the y, okay? So y is adjacent to this angle of 33. So we would have that the cosine of 33 is equal to y over 35, that hypotenuse. Which means, once again, we take this 35, we multiply it by the cosine. So we're going to have 35 times cosine of 33 equals our y, which when we type that in, we will get that y is equal to 29.4 meters per second. Okay? And those would be the components of our original vector. That's how you would find the x and the y. Okay, so let's do an example together. It's called Need a Lift. Do you need a lift? All right. So at a local ski resort, you take a rope tow to the top of the bunny slope. Your displacement vector for this trip has a length of 190 meters and points at an angle of 26 degrees north of east. So if it's north of east, 26 degrees, it's going to be like this. And it says that it's 190 meters, 190 meters and 26 degrees north of east. During the ride to the top, how far have you gone in the horizontal direction and in the vertical direction? So it wants to know our x and it wants to know our y. So we're going to do this the exact same way we just did that other one. So let's do it just trying to use this 26 now, not finding the other angle, and see if we can figure it out, okay? So once again, we're going to have our SOHCAHTOA, and I want to find the x first. So that means that I'm going to do the cosine again. So I'm going to say cosine of 26 is equal to x over 190, which means that 190 times cosine of 26 equals x, okay? So if we do that, we're going to find out that the x displacement is 170 meters, okay? Now we need to find the y component, but I don't want to have to worry about solving for this angle. Maybe I forgot how to solve for the third angle in a triangle, okay? That means I'm going to use sine. So the y is opposite, which means sine of 26 is equal to y over 190. So we're going to do 190 times sine of 26 equals y. And that's going to give us a y component of about 83 meters. So this is how far you traveled horizontally, and this is how far you traveled vertically while you were on this, going up to that bunny slope, okay? Finally, we can talk about how components can actually be turned into vectors. So let's do an example with that. All right, so you plan to cut a piece of plywood to make a skateboard ramp. The ramp is going to cover a horizontal distance of 133 meters and will rise up a vertical distance of 0.380 meters. What are A, the required length of the ramp, and B, the angle the ramp needs to make with the horizontal? So we have been told that it's going to cover a horizontal distance of 1.33 meters and a vertical distance of 0.380 meters. So 0.380 meters. What we want to find is the vector for this. We want to know what this quantity is. Let's call it, since it's a ramp, we'll call it vector R, and we want to find this theta. So how do we go about doing that? Well, once again, we are in luck because this is going to make a right triangle, okay? Which means that to find this, we can use the Pythagorean theorem because this side is 0.380 meters and this side is 1.33 meters. So we know that this would be our C, right? So C squared equals A squared plus B squared, which means we can do C equals the square root of A squared plus B squared, okay? When we do that, we are going to have that the square root of 1.33 squared plus 0.380 squared is going to be equal to the magnitude of this vector R, okay? What we get when we do that is 1.38 meters, okay? So that's how long we would need to make the ramp, 1.38 meters. Now, though, we need to know what this angle is going to be, okay? So if we go back to SOHCAHTOA, TOA is for tangent, and it's opposite over adjacent, right? So if we take the tangent of theta is going to be equal to the opposite of 0.380 over the adjacent, which is 1.33 meters. In order to get theta by itself, theta is equal to the inverse tangent of 0.380 over 1.33, okay? And that is going to give us a theta of 15.9 degrees, all right? And this 15.9 degrees is north of east, okay? So it's going to be 15.9 north of east. So that means that overall, our vector R is equal to 1.38 meters at 15.9 degrees north of east. All right? Now, I have something that I want you to think about before you come to class tomorrow. Okay, so what we're going to talk about is this figure right here. This is a baseball diamond, okay? And each of these sections are 27.4 meters long because a diamond is just a square turned on its side, all right? Now, the positive x-axis goes from home plate to first base, and the positive y-axis goes from home plate to third base. Now, What we want to find is the magnitude and direction angle of the displacement vector of a base runner who has just hit a double, a triple, and a home run, all right? So that means a double would be over here in this corner, right? So we're finding a double, a triple, and a home run, which meant they went all the way around and came back here, okay? That's what I want you to try to figure out before class tomorrow. When you come to class, we will go over this together and then you'll start your problem set. I hope you all have a great day and I will see you tomorrow.